All right. Solid lies between the planes that are perpendicular to the x-axis at x equals 0 and x equals 4, and whose cross sections of the are perpendicular to the x-axis on the interval from 0 to 4 are squares whose diagonals run from y equals negative x squared to y equals negative square root of x to y equals square root of x. So essentially, I have these two graphs. I have the square root of x, which is going to look something like this, and I have the negative square root of x, which is going to look something like this. And then I have these weird cross sections. Now, let's do my bounds from 0 to 4. And I have these cross sections. So I'm going to just draw one cross section who's going to look like squares. So essentially, it's going to be hard to draw this, but it's going to look something like this because the diagonals is part of the cross section, not the base that lies on that cross section. So this cross section is going to look something like that. Let's see if I can redraw that. Something like that. And if I take this and I pull it out and I make it two-dimensional, you're going to get something that looks like this, who's actually going to be rotated a little bit, and then whose diagonal is going to be right here. So hopefully you can see it. That if I pull this little piece out, it's going to look something like this if it's two-dimensional. Now, this length of this diagonal is going to be the square root of x and another square root of x. So this is going to be 2 square roots of x. That's going to be the diagonal. So in order to find the sides of this square, because I need to find the area of this square, you end up having two sides, which I'm going to call s and s. And if you notice, if this is a square, this becomes a right triangle. So I can actually use the Pythagorean theorem. So s squared plus s squared equals 2 square roots of x squared. Now, that gives me 2 s squareds equals 4, and then the square root of x squared is just x. Divide by 2, so you get s squared equals 2x. And then square root both sides, you end up getting s equaling the square root of 2x. So I can replace these with the square root of 2x each. All right, so now the area of each cross section is going to be the length times width, or in other words, if it's a square, it's going to be the square root of 2x squared, which is actually just going to be 2x. So I know that in order to get, I need to add every single one of these little pieces up. So we are actually, if you remember, the volume of x is the same thing as the integral of a of x dx, evaluated from my bounds. So in this situation, my volume of x is going to be the integral from my bounds, which is 0 to 4, of 2x dx, because that's my area. And if I integrate this, I end up getting x squared, evaluated from 0 to 4, and then we end up getting 4 squared, which is 16.